In this exercise, we'll be looking at the initial fire growth and what is, let's say, the first phase of the fires, what will be the diameter of the fire, the perimeter, the length, some of the characteristics of the fire, and especially the forward rate of spread, which is of great interest for firefighting. So in the inputs, we have the basic rate of spread that can be given by different systems, and we have some basic rate of spreads reference values given by different authors. So we can start with 1.4 meters per minute, and this basic rate of spread is with no wind and no slope. So then we have the effects, the acceleration factor, the effect of wind, the effect of slope. So let's look at the acceleration factor. Canadian research was suggesting the value of 0.115. Here we have an acceleration factor of 0.2. So this acceleration factor is very important for the first phases of the fire. So in this case, if we have 0.2, we have an initial forward rate of spread of the fire of 0.9 kilometers per hour in the first 15 minutes. If we change it to 0.1, which is closer to the values that are recommended in the literature, it goes from 0.9 to 0.6. And of course, that acceleration factor has only an effect on this initial phase. After a while, the fire will reach a steady state rate that is not dependent on the acceleration factor. So here, the steady state is 1.3 kilometers per hour. If we change the acceleration factor to 0.2 again, you see that this first value is changed. After 30 minutes already you have the steady state 1.3 kilometers per hour, but that's the steady state value is the same. So the acceleration factor only influences the first phase. So we can now look at the effects of wind and the effects of slope. So we can start with no slope, zero slope, just the effect of wind. And here you have a 1 meter per second wind blowing in this direction, east to west, at a rate of 1 meter per second. Of course, if you increase this speed, you have, let's say, the fire will spread more rapidly, and this is what it will be the final perimeter after 8 hours. If it's only if fire is only affected by wind, if wind continues to blow in the same direction, so after 8 hours, 480 minutes, the area burned would be 2,300 hectares, the perimeter would be 9.5 kilometers, and the maximum distance is 9.5 kilometers. You went almost to 10 kilometers in spread, and the forward rate of spread is now 1.2. So the wind is doing this, is doing his job in pushing fire in this direction. So now what happens if we have also slope? So we have slope 0%, but now we can start having some effect of the slope. So if we have slope, let's say in if the slope will try that the fire will go south, and if the wind is pushing fire to the west, so the final shape will be something like that, where now fire is dominant, but if you decrease fire speed, it will be, of course, the spread will be less, and the fire will spread more in the direction of the slope, upslope. So this is the combination of slope and wind that is provided in many of the softwares that are available, especially Farsight by Finney, that is based on the Rothermel model. And because of that, the effect of wind especially is very much dependent also on fuel characteristics, and so you have to have in the input some fuel characteristics, fuel depth, bulk density, particle density, surface area to volume ratio, and you change those a little bit and see how they affect the final result. So if you just change surface area to volume ratio from 2000 to 1000, you can see that doesn't make any major difference. But if you change bulk density from 20 kilograms per cubic meter to 50, so it's much more dense, the wind will have a much less effect. So this is the type of let's say simulations that you can do with this spreadsheet. This spreadsheet is again dedicated to the initial phases of the fire. That's why we have this acceleration factor, but it's also good to illustrate the relative effects of wind and slope on fire spread.